Hello, pre-calculus students, and welcome to what is our conclusion of the lesson on factoring and finding real zeros of higher order polynomials. And we're going to finish this out with one big example here that just asks us a simple question. Find all the zeros of this. And I really should say, I should really add on to this, give exact values when possible. Okay, if it's not possible, it's not possible. But if it is possible, we need to give and find all of the exact values. Okay. So we're going to start here by having a sort of a educated guess. Okay. So we're going to guess a starting point using rational zeros theorem. Okay, and again, we're going to list out the constant here, a sub 0, which is 90, and then a sub n, which is the leading coefficient, which happens to be 1. Make things very convenient for us. Listing out all these factors, and there's a lot of factors for 90. There's 1, 90, 2, 45, 3, 30. Does 90 go into 4? No, it does not. 5, 18. Okay, and I think there's 6, 15, there's 9, 10. And I think that about covers it. So there's a ton of different factors here. The factors for the leading coefficient is pretty simple. It's just 1. So the potential rational zeros here are just plus or minus 1, plus or minus 90, plus or minus 2, plus or minus 45, plus or minus 3, plus or minus 30, plus or minus 5, plus or minus 18, plus or minus 6, plus or minus 15, plus or minus 9, plus or minus 10. And this is a lot of numbers to check. So it's a good thing that we have a TI-83, a graphing calculator with us here that can help us do this a lot faster. So I'm just going to take that to calculator, enter in this complicated polynomial here. Minus 21x squared plus 12x plus 90. And if you look at here, again, I'm always going to go with the biggest number as my window. It's going to go between negative 90 and 90. So I'm going to set my window to be something, maybe to 100 for the x here. For the y, it doesn't really matter at this point. Well, actually, it might help. Let's see. I know that the y-intercept is going to be 90, so maybe I'll do the same thing here. And you can see it looks like the graph is really bunching up there very close to the y-axis. So that means all of the zeros are going to be there. So now I can zoom in. Oops. And this will perhaps give me a better picture. So there we have it. Okay. And it looks like there are 1, 2, this section here looks like there's 2 zeros here, but I'm not sure. So it looks like, and these are all whole numbers here, so it looks like 1, 2, 3, 4, 5. Let's see. 5 work? Yep. So 5 is a 0. Okay, that's 1, 0. And maybe negative 1, 2, 3. Maybe negative 3 is another 0. And negative 2. Nope. And that's about it. Looks like all the other ones are going to be irrational. So these are the rational zeros. And I'm probably going to have 2 irrational ones. Okay. And my job here, our work here, is to find them all. Okay. So I'm going to show you how to do that. So since we have these, we're going to use synthetic division to factor. So after we find this, I guess I can list this out as a step-by-step process. Here we can use synthetic division to factor. And I have two numbers here that I can use synthetic division with. It actually doesn't matter. So I'm going to use 5 first. This is 1, -2, -21, 12, and 90. Okay. And as always, I'm going to check this. This is x to the 4th, x to the 3rd, x squared, is that right? X, and this is x to the 0th. Okay, so I'm good there. All right. So now I can do this. Bring down the 1. 1 times 5 is 5. -2 plus 5 is 3. 3 times 5 is 15. -21. This is plus 15 is -6. 6 times -6 times 5 is -30. 12 plus -30 is -18. -18 times 90 is -90. Sorry, -18 times 5 is -90. This is my 0 remainder, and that is very, very good. Okay, so at this point, I factored it into this is x to the 3rd, x to the 2nd, x to the 1st, x to the 0th. So now I know that f of x is equal to one of my factors, x minus 5, times x to the 3rd plus 3x squared minus 6x minus 18. Okay? Now, I can go further by factoring this. And so I have another factor here that's rational, so I'm going to use synthetic division again. So I'm going to repeat synthetic division with other zeros. And I can actually continue this right here. So I'm going to use -3 right here in this box and just continue synthetic division one more time. Bring down the 1. 1 times -3 is -3. 3 plus -3 is 0. 0 times -3 is 0. Add gives you -6. -6 times -3 is positive 18, and this gives me 0. So let's see what this means. This is x squared. This is x, and this is x to the 0th. So now I know that f of x is equal to x minus 5. That's my first 0 that I'm given here, first factor, times x plus 3, that's this second one right here, times x squared minus 6. Now it just so happens that I can also factor this again. I can factor this by solving for, let me use a different color here. I can factor this by using any method that I want. I can set it to 0. X squared minus 6 equals 0. X squared equals 6. X equals plus or minus the square root of 6. Okay. So it says to find all zeros, and here they are. Positive 5, -3, positive square root of 6, negative square root of 6. Okay, so this answers that question, and I can now rewrite this in complete factored form. F of x is equal to x minus 5 times x plus 3 times x plus the square root of 6 times x minus square root of 6. And you can see from this, this is completely factored down. You can see this has 4 zeros at 5, -3, negative square root of 6, positive square root of 6. You can look at the multiplicities. This has a multiplicity. All of them have multiplicity of 1, and you can look at this problem now using the methods that we learned from sections 2.3 and a little bit of 2.4 to completely analyze this, to find the zeros, to find all of the detailed information that we need to do. Okay, and so this is again, this is a pretty long and somewhat of a tedious process, but the reward, or sort of the payoff here, is that one, we get all of the exact values. Okay, this value here, there is really no way to find this without the algebraic process of factoring it down. Okay? And the other reward that we get from this, which we will not see until the next section, is what happens when we have complex solution. What happens when you have imaginary numbers mixed in here. This is the only truly effective and complete way to do this. So thank you for watching. Have a wonderful day.